Hi, this video is for explaining the Bayesian belief network based upon the Bayesian theorem. The Bayesian belief network is probabilistic graphical model representation for denoting the set of features and its conditional dependencies using a directed acyclic graph. So this is here all are the variables. All are the variables. Here three variables are available in the given data set. In all three variables are denoted in the form of directed acyclic graph, and also it can be represented the um, direct conditional dependencies, which is also called Bayesian belief network or decision network or Bayesian model. It solves the decision problems under uncertain knowledge using probabilistic events. Bayesian network can be used for building a models from the given data set. It is having two main components. One is directed acyclic graph. So here the graph is constructed by using the variables. So three variables. Here this is having only one direction. So and also there is no connectivity, I mean cyclic connectivity. So there is no connectivity between this. There is no cyclic connectivity. So it is called acyclic graph. So this one is cyclic graph. Suppose if I am having the nodes like this, right? So this is called cyclic graph. This is called cyclic graph. There is a cycle. There is a cycle. So it is a cyclic graph. So there is no connectivity between these two nodes. So that's why it is called acyclic graph. Since it is using the direction, it is called directed acyclic graph. Then which is having one more component, conditional probabilities table. So here suppose if you are having the values for this variables, that variables will have the probabilities value that will be mentioned in the form of probability values. So these values are stored in the table. That table is called conditional probabilities table. So the combination of directed acyclic graph and a component conditional probability table is representing the joint distribution of variables. This diagram is called influence diagram, which is representing the Bayesian network to solve the decision problems under uncertain knowledge. Here each variable is assumed as a node, and the connectivity between the node connectivity between the variables, this connectivity between the variables is called edge. Here each variable is a random variable which can be continuous or discrete. The directed edge provides you the relationship or conditional probability between the features. Each edge representing that one node directly influencing another node in the diagram. If there is no directed edge, then that nodes are independent with each other. For example, in this diagram, this is one graph and this is another graph. So two graphs are there. Here the weather is one of the feature which is not depending on any other variable. But here toothache and catch are conditionally independent. Here toothache and catch conditionally independent given cavity. So here the parent is cavity. Toothache is depending on the cavity. Like that, catch is also depending on the cavity, but these two are conditionally independent on each other. The Bayesian network contains two components. One is causal component. Causal component is like a variable, so which is describing the graph structure of the given domain. That means dependencies between the features. Another component is actual numbers, that is the numerical probability, conditional probability table, numerical probabilities. Each node is having conditional probability distribution. That value can be represented, the value of the variable I given parent of that particular variable, so this Bayesian networks working based upon the joint probability distribution and also conditional probability distribution. Joint probability distribution is denoted as for set of variables features x1 x2 xn, then the probabilities of different combination of these features x1 x2 xn can be represented using joint probability distribution. The probability of these variables n number of features can be represented using the joint probability distribution. Feature 1 given feature 2 etc feature n multiplied with probability of x2 to n number of features. Like that, this term can be represented by probability of x2 given x3 to n number of features, then etc probability of xn minus 1 given xn, finally probability of the last feature. So we can represent the joint probability distribution for n number of features in this equation. So here the BBN is representing full joint distribution over random variables more compactly using the product of local conditionals, and compute the local parameterizations using Bayesian belief network that encodes conditional and marginal independencies among the given features. When the feature A and B are independent, we can say probability of A comma B equal to probability of A multiplied with probability of B. When two variables A and B are conditionally independent, given C can be represented one of the way, probability of A given C comma B equal to probability of A given C, and another way, probability of A comma B given C is defined as probability of A given C multiplied with probability of B given C. So the joint distribution and the conditional distribution is mostly used in the Bayesian belief network. Thank you.